Hello, everyone. Thank you for tuning in to this episode of the Amazic podcast. I'm Twain Taylor, editor at Amazic, and we bring you the latest and the greatest from the world of Kubernetes, cloud native, and containers, all those good things, DevOps, platform engineering. Those are the things we talk about. If you like what you hear, head over to our website, amazic.com, and you'll find a whole lot more conversations like this that we've been doing now for 2+ years. We've spoken to a lot of industry uh, vendors, small to big, open source projects, all of them. So go and check out all that we've covered thus far. Today I have with me Itiel Shwartz, who is the co-founder and CTO at Komodor, and that's
Mhm.
spelled Komodor. And the website is komodor.com. So go and check out the website if you like what you hear. Itiel, it's great to have you with us. Thanks for joining. Yeah, I'd like to get us started with just asking you a bit about yourself. Give us an intro of who you are and your background, what you've been up to thus far.
Yeah, sure. No problem. First of all, happy to be here. My name is Itiel Shwartz, like you said, CTO of Komodor. I've been doing DevOps or infra or backend, whatever you want to call it, for the last decade or so. I worked
Mhm.
in very big companies such as eBay, and I worked in a couple of very small startups. The last one, Rookout, was acquired recently by Dynatrace. And over the years, after working with bare metal and so on, I found Kubernetes 8 years ago when Kubernetes was quite a new project, and I really fell in love with the technology and the ecosystem. So I'm a Kubernetes fan ever since. And almost 4 years ago, I decided to team up with Ben Ofiri, which is Commodore CEO and a long partner. And we co-founded Commodore together in order to simplify Kubernetes for its users. So overall, technology fan and a big Kubernetes fan, but that's pretty much it.
All right, interesting. So Kubernetes, right? So it's been growing really fast. There's great, like a lot of adoption for Kubernetes,
Yeah.
and it is quite powerful. And it's kind of like the standardization layer within cloud today. Everyone's standardized on Kubernetes for container management. So along with that, though, the while it does simplify some things, it complicates a bunch of other things. And
Mhm.
so there's two sides to the story of how Kubernetes has become popular and what that means for organizations. Can you describe for us what you see out there in terms of Kubernetes usage, the good, the bad, and the ugly? What are some things that go wrong? What are some things that it's great at? What are you seeing out there?
No, it's a great question. I think the power of Kubernetes and the reason why it's so easy to shoot yourself in the leg is it's very easy to get started. For anyone who didn't start working with Kubernetes, all you need is to ask the cloud provider for a cluster, like one button. Then you create a very small YAML, like 10 lines, and you are getting an application up and running with a lot of very powerful features such as readiness check and health check and easy scaling and load balancing, a lot of things that, 10 years ago, you should have worked days, weeks, even months in order to create only a single application. So the
Mm,
power of Kubernetes is the fact that it looks super simple, and that is why a lot of organizations are jumping to the Kubernetes without really understanding what's beneath it. And
mhm,
the problem with Kubernetes is it's a bit of a weird layer that includes both application, like workloads, your Flask server, Spring server, Express, whatever, Gin, server that is up and running. And on the other front, and on the other side, you still have infrastructure pieces that need to run everything. You have the nodes, you have the cluster, you have secrets, you have config. And because Kubernetes is so easy to get started, at the beginning, you're like, oh, now managing resources in the cloud is going to be much easier. In reality, a lot of the times it's the opposite, because Kubernetes is like a very complex Lego that you need to sort of the pieces together in order to make it into something beautiful. And people are very focused on the compute layer itself, the ability to run a specific container, and they forgot about the rest of the supporting like infrastructure. And once you forget about it, you are learning it the hard way when you are starting to waste a lot of time, like making sure that your cluster are up to date, or your certificates are being renewed, or your secrets were rotated. Like there are a lot of different things that you need to take care of, and that are simply like you don't see it when you start. And also there is a lack of experience in Kubernetes. Like in the end of the day, the technology is still quite new. There aren't a lot of Kubernetes experts. The one that you can like get are super expensive. So like a lot of different things are harming Kubernetes adoption. But on the other hand, I would say Kubernetes is like by far the most adopted, I think, technology now for a big organization. Like everyone have Kubernetes or is trying to migrate into Kubernetes. Yeah, it was a bit of a long answer, Twain. So let me know if you're going to deep dive.
Yeah, those are quite a few things you unpacked there. But to talk a bit more on those lines, so you mentioned how there's there's it's a mix of it's an interesting mix of dev and ops teams and different concerns there. Can you also talk about these two teams within organizations and their priorities and concerns and how sometimes it's in conflict, dev and ops teams, and just some of the ways you can actually, solve those challenges.
Mm-hmm. So repeat the question again. Sorry, like how
Uh,
to.
just about development teams and operations teams, just the
Mhm.
different priorities that they have. What are some of the different priorities and what are some areas of conflict between these two teams?
Yeah, sure. So a developer will be focused mainly in his workload. Like if you look at a developer center or like center of attention, it's around how can I release my features as fast as possible to production and bring more value to the company, right? Like that's the name of the game here. On the other side, operation people usually are much more macro level oriented. Is all of the system up and running? Are my cluster healthy? Are all teams like or all different applications are running as expected? So just of the of the bat, like there's a very big difference in what drives each one of the personas. So this like causes a lot of like cascading problems, right? Because when pod and application fails in Kubernetes, the first thing a developer will do is probably blame the DevOps, right? Like it's the easiest thing. Like my application running on Kubernetes is not working as expected. In reality, the DevOps will be probably a bit frustrated because they will say something like, "Yeah, but you wrote the bug, you misconfigured something." So we see a lot of tension between those two parties. And I
Mm,
think that the correct way to solve it is a combination of education and like proper tooling.
mm. All right, all right. Could you just repeat the last words? It's a combination of education and proper tooling, is it?
Yeah, proper tooling, exactly.
Right. Okay. Okay. Interesting.
Mhm.
Yeah, I'm sure going to get into more of that in just a bit, especially the tooling part, because that's what you built with Commodore, a tool that can bring these teams together and manage all of this complexity. Before we get there, I wanted to just talk a bit about just the idea of drift. Um,
Mhm.
that when something is deployed and it goes out into production, but it gets changed in production. I think that is probably what drift means, but you can probably explain that better. Uh, Tell us a bit about drift in Kubernetes, how it happens, why it happens, and what do teams deal with when it comes to drift?
Yeah, so I think drift is even like maybe like a bigger problem. I think drift is a term that is used every time where you have a specific desired state that you want to reach, and in the reality you are keep on like going further away from that desired state.
Mm,
So one example might be something easy, like you have a new image that you released. You want to update your Kubernetes cluster, but now the deployment failed for some reason. So now you have a drift, right? Like you have version 1.1 in the cluster, you want to have version 1.2, but like the deployments fail. And maybe as time progresses, you keep on failing. So this drift only like becomes larger and larger and larger. So it can be in terms of application. It might be around the cluster version themselves. It can be the node pool versions. It can be the supporting like infrastructure. In Kubernetes, when we're talking about drift, there are probably 5 or 6 different like drift types. Application, best standards, infrastructure, Helm or Argo, which is some weird combination. So we see a lot of different drift scenarios. And the hard thing about Kubernetes is that a lot of the times you are running in a multi-cluster environment. So you might be in a different state in each one of the cluster, meaning again, like more drifts and more time consumed trying to find and to solve those drifts. And for large organization, for what we call like Kubernetes fleet operators, this is a very big problem. If you have hundreds of clusters, it is very painful.
All right. Yeah, so we've spoken about Kubernetes and the adoption. We've spoken about dev and ops teams and these different priorities they have, and you just explained about drift and how that comes into the picture. I also want to touch on something that has been gaining a lot of traction in the past year, which is artificial intelligence and how that comes into the play in all of this. A term that has been becoming popular is AI ops, artificial intelligence ops. Do you see that as something that has a lot of potential to really solve some of these challenges in a very effective and an easy way? Tell us a bit about your view on AI and its possibilities here.
It's a really like a great question because in the end of the day, AI is a promise have been in the operation in the Kubernetes space for years and years. Like, how can I take this like automated way of solving issues and try to make DevOps life easier? So the concept itself is not new. I think what is new is the technology behind it. Using tools like Claude or OpenAI or Gemini, or it doesn't really matter. I feel that for the first time, we have a chance of gaining bringing like real value to DevOps when it comes to their day-to-day operations. And on the other side, Kubernetes is so complex that it's very easy for AI models to hallucinate or to give you the relevant, like the wrong recommendation or the wrong evidence, or like it's very easy again to shoot yourself in the legs. So I think you need like a very, 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 very focused domain and focus and like a very strong team in order to create something that is really meaningful and like that can work.
All right, interesting. I'd like to see how you kind of bring all of this together, and would love to see a demo of Komodor. But before we get to the demo, if you could give us a brief introduction to Komodor, what it does, and the approach it takes to solving some of these challenges that we just spoke about, that'll be a good starting point for us, and then we can move on to the demo.
Yeah, sure. So Komodor, what we do is we simplify Kubernetes. We simplify Kubernetes both for the operation people, the DevOps, the SRE, the platform engineers. We help to make their life easier. On the other side, we help the developers themselves, the people who outnumber the first group 10 to 1 around solving issues and around solving problems. So Komodor comes to help organizations in general in their adoption to Kubernetes, specifically enterprises or like large environment. And we do that by focusing on 4 main pillars. We help with configuration of the user management inside of Kubernetes. On top of that, we have the ability to optimize different resources, to make sure that everything is running according to standard and without drift, and to help with the real-time investigation, real-time troubleshooting. So for each one of those different pillars, Komodor is the best-in-class solution when it comes to Kubernetes. So this is what we do in a high level. Now, does it make sense, Dwayne, or do you have
Yeah, it does. Yeah, yeah, sure. Do tell us more.
Yeah. So, like I said, it was born by a combination of my personal pain as a long-time Kubernetes users, and also something that we see in the market, like the pain and the challenges that organizations are facing when they're trying to migrate to Kubernetes or when they're trying to adopt Kubernetes for the first time.
Yeah.
like we said earlier, like there's a very big difference between developers and DevOps. And Komodor is the only like solution that is very dev focused, meaning how can I take a clueless developer who is not an expert, who didn't do all of the Kubernetes certification and so on, and to help him or her to solve issues in Kubernetes without escalating to anyone else. That's the dream, that's the goal.
Okay, okay. When it comes to like managing Kubernetes, there's a lot of options, especially, many probably default to, let's say, AWS's Kubernetes management solution or Google Cloud because they simply run their infrastructure there for many years, and so they're probably thinking of that. But for someone like that, right, what would you say is the appeal for, why they should probably think of Commodore rather than just going with the default option with, like, let's say, one of the big cloud vendors? What's the approach that Commodore takes that really sets it apart?
We do only Kubernetes. Like I don't know serverless, I don't know AWS like bare metal, whatever. We do only Kubernetes, and we focus a lot around like the day two operation. Meaning, we assume you already have a cluster. We help you to set it up better, to set the user management, best practices, like all of those things we do help you with. But because we focus only on the day two, only around solving issues in Kubernetes and configure Kubernetes in the right way, it allows us be very accurate and very very focused, which allows us to actually deliver. I think a lot of the vendors are promising things, right? Like that's easy to promise. When it comes to Kubernetes, because it is so noisy, because so many things are always happening inside your cluster, it's much harder to deliver.
All right. Got it, got it. Sounds interesting. I'd love to see some of this in action, and if you can give us a demo or a walkthrough of your product, I'd be really interested to see that.
Yeah, sure. So let's do like something like I think we have like 5 minutes, right, for the demo flow.
Yeah,
So
sure.
I'll try to do it like a bit fast because usually it does take a bit longer to work.
Okay, okay.
So this is the Komodor platform. In here, you are able to see all of the different clusters across all of the different regions, cloud providers, vendors, like everything in one single place. And for every cluster, we provide two main things, like the critical issues, the real-time issues, problems that happen right here, right now. And on the other side, we have the reliability, which is Komodor way of measuring, helping you to measure the posture of your cluster. How well is it being configured? Is everything running according to best practices? Do you have any problems or issues that are now stopping you from working properly? And because we don't have a lot of time, I will jump to another screen, Komodor, which is the service screen. This screen basically allows you to see all of the different services that you have across regions, across clusters as well. This screen is great for the DevOps. It's great for the SRE. It's really bad for the developer because there's simply too much noise here. And for that, in Komodor, we created what we called a workspace. A workspace might be something like a specific team or a group or an Argo application or a Helm chart that allows you as an expert to narrow down the scope that your developers are able to see. And once you do that, you allow them to be much more efficient because they don't need to see everything. Once they go into Komodor, they see only what they should care about to see. So in this example, we have 20 services, 20 of them, some of them are unhealthy. Let's go into one of them. And the first thing that I see once I go into one of the unhealthy services is that it is not working correctly, right? And luckily for us in Komodor, you have what we call a service timeline. Service timeline is a bit like a time machine for Kubernetes. It allows me to understand and to see everything that happened in this specific service over the last 24 hours. I can see things like changes, like something that changed inside the cluster. I can see problems, and I can also see integration with other external tools. In this example, I can see a deploy that failed, and I have the ability to see exactly what changed as part of this deployment. Very similar to what you have in GitHub, but we take this data directly from the cluster. More than that, you are also able to see different changes that happen for related resources, things like config map or secrets or HPA and so on. You are also able to know that, and also the changes from a GitHub perspective. And I'm not sure if like you are able to see that, but while I show you everything was happening here, there was some loading bar here that kept on changing. This is Komodor GenAI, Claudia. that allows our users to simplify troubleshooting process using GenAI. In this example, Claudia is trying to help us to understand why is the deployment is failing. And we can see here like a full understanding. Deployment had only one available replica, font condition, container logs, and then it tells me, hey, the config map contains incorrect API rate limit value. And again, there's like the relevant evidence that helped me to understand what's happening here. And I can even go to Komodor and fix and solve the problem. So in this very like, like small drawer or like a very like small piece of information, we're able to collect data from 6 or 7 different tools into one place, and also to digest the data in a way that makes sense for our users, meaning in a way that allows our users, even if they are not experts, to take an issue and to solve it end to end. Komodor, for every issue, for every problem, and go to another pod that is unhealthy, but for every issue, for every problem, we're able to tell you like what happened, why did it happen, and what you should do now in order to remediate the issue. That's what we do. That's what we pride ourselves. And this also sets us apart from anyone else. Like our ambition is basically very, ambitious, right? Like to be this single source that will tell you everything regarding your cluster. If you'll ask our customers, we're actually able to deliver on that promise. Other than that, there are like a lot more capabilities. Like I didn't cover user management or infrastructure issues, or cluster upgrades. And Commodore has a lot of different capabilities that again are both for expert and non-expert alike. Any questions? Because I do know that I try to keep it quickly.
Yeah, no, that's a great demo in just a short time. Really good use case there for Claudia AI, giving us exact reasons for why a deployment failed. Really good, really cool stuff there. What else? Could you tell us one more thing that Claudia AI can do
Yeah, sure.
right?
No, that's a great question. I will give another very cool example, maybe, of a different kind of problem. This is more around certificate issues. This is exactly where you have the I will say like tension between application to infrastructure. Certificate is somewhere in between. Like it's something that your Nginx or Ingress need to mount in order to make it work. In this example, we can see that the cert manager is not working correctly, what impacts the secret creation, what is going to impact the services, like the dependent services. So this is an end-to-end flow that explains to us what happened in the system, not from I have an application that is not working correctly perspective, but from a much more what core services in my application are not working correctly. Again, Cloudy gives you like related evidence and suggested remediation.
You mentioned, your platform has so many features, and some of them are for expert users, some of them are for new beginning users. And I was wanting to know if the admin can actually control what an expert sees versus what a novice sees, the number of features.
That's a great question. So in Komodor, we are able to configure all of your user roles, policies, and actions, everything in one single place. And more than that, you can do things like given temporary access. For example, I can give an access only for a short, limited amount of time. So again, you are able to control in one place all of the different RBAC and user management across your clusters, no matter where do they sit. And you can even see full auditing of how your users are actually using the platform. And this allows you what we like to say, like a delegate with control. Allow your users to have the relevant controls, but while you still have all of the guardrails in place to make sure everything is working as expected.
All right, got it. Wow. That was a really cool demo, and there was a lot of interesting things you showed us there. So yeah, listeners and viewers, if you like this and you want to know more, definitely reach out to Commodore. They'd be happy to tell you more about this and give you a more in-depth demo of their product. We just scratched the surface, I think, but it's very interesting what we saw. So yeah, we're winding down. We're reaching like the end of our conversation here, Itiel. But before we go, though, I just want to get your take on, as you look ahead, the future and what's coming up for Kubernetes management. What do you see down the road, and what are you guys looking at as the next phase within the space of Kubernetes management, or even within your own product of Komodor?
Um, it's a hard question. It's a hard question because we want to achieve so much, but in the
Mm,
end of the day, it's around really taking the big promise, which is Kubernetes, and to make it into a reality, into all of the organizations that are using it. So like that's where we aim to be. And we
mm.
want to simplify Kubernetes for every person who uses it inside the organization and for every organization. That's the goal. And we are adding more and more features, more and more capabilities while having this goal in mind.
All right, all right. Yeah, yeah. Just more of what made you really start
Mhm,
simplifying Kubernetes. That's really yeah, a good thing, I think, just to keep your focus on the basics and the
mhm,
fundamentals. I think that's really important.
mhm.
Yeah, that was a wonderful conversation. Thanks so much for joining us. But before you go, Itiel, just one question that I want to ask you, which to get to know you a bit more is, what would be your alternate career path if not for your job in tech? What would you be doing otherwise?
Oh, that's a great question. I think a lawyer, like my father. That
Yeah,
was like the next plan.
yeah, yeah. Interesting. That's a whole big universe itself. Which part of law are you most interested in?
Um, like my father was a prosecutor, so this is like obviously quite interesting. I'm not sure. I'm not sure because I really don't like working for the government, which is if you want to be a prosecutor. So I'm not sure. And luckily for me, I really enjoy my day job.
All
So
right. Yeah, yeah. You don't have to consider all of those things, but yeah, wow, interesting to know. You have a fascination with law. All
yeah,
right. Great. Thanks so much for joining us again, ETL. It was a pleasure talking to you, and I want to wish you the best with building Commodore. If you launch anything new, reach out to us and come back on the show and tell us about it. We'd love to have you back.
pleasure. Thank you.
All right. Thanks all of our listeners and viewers for tuning in again, and we'll see you on the next episode. Bye-bye.
Bye.
Stopping the